Water quality is an indicator of how well we're living with our landscape. And there are signs Idaho's lakes are in trouble.
You could see the lake turning color, and it's starting to look more like pea soup instead of water.
When you have lakes like this that are basically becoming toxic because of the algae, we really have to find out how to stop it.
Scientists are using all their tools to understand what's happening.
You don't get a second chance at it. Once it goes bad, it's very difficult to recover.
And they're seeking solutions.
Swimmable, fishable, drinkable water is the ultimate goal.
The responsibility for water quality rests on each and every one of us.
We are trying to protect this for the future generations.
Outdoor Idaho examines the health of our lakes.
Funding for Outdoor Idaho is made possible by the Laura Moore Cunningham Foundation, committed to fulfilling the Moore and Bettis family legacy of building the great state of Idaho, by the Friends of Idaho Public Television, by the Corporation for Public Broadcasting, with additional funding provided by the National Science Foundation and the National Science Foundation's EPSCoR program.
From the air, they resemble shimmering jewels of blue. But if you take a closer look, a really close look, you may discover that these lakes, like so many waterways in the world, are in trouble. Hi, I'm Bruce Reichert, and welcome to Outdoor Idaho. These magnificent northern lakes attract thousands to their shores to live, to work, to recreate. But a microscopic organism is affecting water quality, and that has folks wondering if that could impact the economy of the entire region.
The microscopic life in a lake lives off a combination of nutrients, like nitrogen and phosphorus. Some nutrients come from the air. Others are released when roads, logging, and other activities disturb the soil. That soil and the nutrients are carried from streams into lakes. Chemicals like fertilizer runoff also add to a lake's nutrient load. The lake's water quality is endangered when these nutrients get out of balance. Mark Solomon is the Associate Director of the Idaho Water Resource Research Institute at the University of Idaho.
Algae are simple plant organisms that have been around for billions of years. They've played a very key role in our world because prior to their existence, there wasn't enough oxygen in the atmosphere to sustain animal life. Cyanobacteria, or blue-green algae, are the reason why we have an atmosphere that we can live and breathe with.
These single-celled organisms are the bottom of the food web. In a healthy environment, blue-green algae are kept in check.
They're taking the minerals from the earth and transforming them into nutrients and food that everybody else can use. But along the way, they have to spit things out. And what they're spitting out are toxins that can be dangerous to plant life and to animal life.
Blue-green algae, or cyanobacteria, can be so toxic that blooms in a watering hole in New Mexico killed more than 100 elk. And toxic blooms threatened participants training for an Ironman competition in Ohio. As blue-green algae grows, it causes a green scum to form on the surface and lower in the water column.
The act of growing and dying and decomposing creates a feedback loop in the lake that continues to strip the oxygen out of it, creating an even better environment for those algae to keep growing.
And if blue-green algae growth continues unchecked, fish and plants eventually die. Recreational waters become unusable, and surface drinking water supplies become contaminated. And the cost to deal with toxic blue-green algae is not cheap. One estimate suggests these algae blooms cost the U.S. economy more than $2 billion a year. To a degree, blue-green algae blooms can be found in all of the northern Idaho lakes. But the hardest hit is Fernan Lake, just outside of Coeur d'Alene. It's so bad that Fernan Lake residents Susan and Mark Andrews fear these microscopic organisms could cost them their way of life.
You could see the lake, in a sense, turning color. It's like you're looking at it and you could see it getting thicker, and it's starting to look more like pea soup instead of water.
The Andrews and other area residents organized. They wanted to find out why their lake was in trouble.
I believe the algae bloom has caused us to take a second look at what's happening and to want to do all that we can to keep the lake pristine.
Fernan Lake's dynamics, how waters move in and out and from where nutrients come and go, are not well understood. So lake managers and Fernan Lake residents reached out for help.
It was the University of Idaho who took the interest through the Miles Project.
Frank Wilhelm is a limnologist, a scientist that studies inland waters. He and his team of graduate students are here to test the waters in Fernan Lake.
Dead catfish right there. Or bullhead, something.
And they're labeled?
Yep, they're all labeled.
Okay.
And we have acquired a position, and we're ready to go.
Fernan Lake is small by North Idaho standards at about 380 acres. It feeds into nearby Lake Coeur d'Alene. Fernan Lake is prized for boating, swimming, and it's the most heavily fished lake per unit in the state. Toxic blue-green algae now bloom in the lake upwards of 100 days a year.
The contact limit for drinking water is 0.3 micrograms per liter. We're at 7.6. Nobody should be drinking this water.
When a bloom is on, recreationists can still use the lake, but they have to be careful. They should wash their skin after contact. People shouldn't water ski because they might breathe the toxins into their lungs. And pets are particularly in danger because the algae sticks to their fur and they are more likely to get a toxic dose.
When you have lakes like this that are basically becoming toxic because of the algae, we really have to find out how to stop it.
Graduate student Tria LaCroix is trying to answer a key question.
I am looking at the amount of phosphorus that has entered and left the lake over the course of 1 calendar year.
She's taking samples from the top, middle, and bottom of the water column.
6.2, so we'll do about 5.5.
Perfect. What we think is that Fernan probably doesn't have too much of a difference because of the frequent wind events that it experiences, and in theory the wind is constantly making the lake mix, and so the phosphorus should be pretty evenly distributed.
LaCroix takes a water sample with a Van Dorn water sampler. It's basically a clear tube with 2 rubber ends and a remote trigger. When she drops it to the right depth in the water, she sends a brass weight down the line, and that sets off the trigger that snaps the end shut, capturing the water sample.
We're looking at establishing a really detailed water budget so we can figure out exactly what streams and tributaries are contributing how much water and how much sediment, how much phosphorus. We're also measuring the lake outlet, how much leaves the lake. So we're basically doing a mass balance. How much comes in, how much leaves, and how much is left in the lake itself.
The crew does 2 samples at each depth. One sample looks for total phosphorus, so they'll be testing for everything in the water. And the second sample is filtered, so all that is left is the water itself and the dissolved phosphorus. The samples are then sent to a lab for analysis.
Research on cyanobacteria is relatively in its infancy, so we're just discovering what the toxins are. We know how to analyze for them, but the tests are still relatively expensive.
5.8?
Also, we need a plankton tow and a surface grab.
I gotcha.
Over the course of a day, the team takes 188 samples.
I've discovered that quite a bit of phosphorus was stored. About 80% of what came in remained in the lake over the course of the year.
And that's not good news because it shows as more and more phosphorus comes into the lake, it's not being swept out. And that means phosphorus levels are building up year after year. And that means better growing conditions for blue-green algae. But this research will still help lake managers look for solutions in the future.
Whenever you go out, you want to figure out how many samples you need to take to get an accurate view of what's going on in the lake. So if you can take one sample at one depth and get an accurate view of the entire lake, it's way more efficient.
Wilhelm hopes his team's research will eventually make a difference. But for Fernan Lake, the answers aren't coming anytime soon.
Well, it's been 100 years in the making, and it's going to be a tough solution.
For Lake Coeur d'Alene, the situation is different. Tailings from mining that started in the 1800s deposited approximately 75 million metric tons of contaminated sediments in the bottom of the lake. And according to Coeur d'Alene tribe limnologist Dale Chess, that high metal content actually inhibits algae growth.
The problem with that is that we're cleaning up the metals in the upper basin, which is reducing that inhibition. So we can potentially grow more algae given higher nutrients.
The Coeur d'Alene tribe and the state of Idaho are jointly in charge of the lake's water management plan.
It gives a clunk that tells us it's closed.
Scientists from both agencies monitor the situation. This day, they both are taking water samples and comparing data.
We are really measuring the lake's metabolism. How deep is the phytoplankton in the lake? And then how much oxygen is being used in the deeper parts of the lake. Because we know that higher amounts of algae growth and death and the associated organic matter with that reduces dissolved oxygen in the sediments of the lake.
And then we'll start to look for the dissolved oxygen levels to decrease and pH to go down as well.
We want oxygen levels high in the bottom of the lake because high oxygen levels work kind of like a cap on the contaminated sediments that are in the bottom of the lake. The higher oxygen, the more the metals stay in the sediments. If your oxygen drops down to lower levels, your metals will come out of the sediments and you'll have higher metal levels in the lake, and that will reduce water quality for the lake and impact the lake's ecology.
Everything in? Yeah, we're good, man.
Understanding the conditions on the bottom of the lake is so important that these scientists are taking a closer look.
Today we're sampling vegetation in Nechin Bay in order to get a better feel for what the biomass of the vegetation is, what its species distribution is, and what the basic ecology is of this bay. We get out a 1 meter square. We collect all the vegetation from inside that 1 meter square. And we'd get it in every depth range, 30 feet, 27, 21, by threes up to 3. And by doing that, we can get a statistically valid measure of the biomass in the lake at each of the depth ranges.
When we're pulling those plants, the sediments get churned up. So you really can't see, so you're actually kind of feeling around with your hand. You just feel for the plants that are there and you pull them, and then you have another diver there and you're basically just stuffing the plants in the bag. But it's a pick clean process.
I often go down to the bottom and look up and think that every time that I'm up there on the surface swimming, I don't think about what's under me or how far down 30 feet is, and I get down to the bottom and it is a whole different world and a different perspective.
You get on the surface of the water like this and it's beautiful out here, guaranteed, but you get down there and it's a different world. When I'm not thinking about the science and the technicality of being underwater and the safety of being underwater, I think how beautiful it is. You have the fish swimming around you, you have little crawfish fighting off the bass. You have big stands of wavy vegetation, 12, 15 feet high. It's just a cool, crazy place. I love it.
Back on the boat, the scientists bag up the plants to send to a lab for analysis. Scientists on the Coeur d'Alene tribe's boats also bottle up their water samples for the lab. Scientists have data about water conditions in the lake going back into the 1990s. Jess says the trend shows phosphorus levels increasing and oxygen levels decreasing. That's good news for algae and bad news for the lake's water managers.
You don't get a second chance at it. Once it goes bad, it's very difficult to recover.
The tipping point would be when the lake moves into that state where the internal cycling of nutrients is driven by low dissolved oxygen. Coeur d'Alene Lake is not at that tipping point. We're still trying to predict where that tipping point is. We don't even want to get close to it.
Scientists will analyze the samples collected today, and the data will help shape the lake's management plan. But water quality manager Thomas Herron says to make sure the toxic blue-green algae problem seen in Fernan Lake won't happen in Lake Coeur d'Alene, people need to get involved.
I think the first and foremost is to minimize your footprint along the lakeshore. If you're a lakeshore resident, be conscious of the nutrients that you could be inputting into the lake, because nutrients are really what accelerate the demise of lakes. I think that once people understand what it is that we have and what it is we can do to protect that they're on board. They will do what they can.
The lake has value to the tribe and has since time immemorial, and it's their homeland. So obviously we all want our homes to be safe and sound and free of pollution. We are trying to protect this for the future generations and current generations of the tribal membership. And the ancillary benefit of that is everybody else gets to enjoy a beautiful lake.
Just 6 miles northeast of Coeur d'Alene is Hayden Lake. Its natural beauty attracts thousands of visitors each year. The water quality in the main body of the lake is healthy. But along the more developed shorelines, around the shallower bays, residents are seeing greater algae growth and other issues. In 1998, Hayden Lake was classified as threatened water quality as defined by the Clean Water Act.
There was more phosphorus coming into the lake than they wanted to see. That means that the lake is dying quicker. It is what creates algae blooms, which will fill the clean waters and create problems, even health to animals and people.
Lake managers looked at ways to reduce the phosphorus levels, but many involved adding chemicals to the water. That can compromise water quality and can be very expensive. So residents of Hayden Lake wanted to try a more natural approach. Adrian Kronebaugh and the Kootenai Environmental Alliance did some research, and in cooperation with residents, installed floating treatment wetlands.
They'd been used for decades in wastewater treatment plants, which treat the same pollutant that we are concerned about here in Hayden Lake, phosphorus. We have 4 floating treatment wetlands that we've been observing over the past 4 years. Initially, we did see a decrease in phosphorus in the waters where we placed them, an increase in visibility, clarity in the water, and also a decrease in bacterial E. coli, which were all thumbs up.
I'm encouraged by what I see. I believe that there's places where we have man-made phosphorus coming off the more populated hills, where we can put these floating wetlands and absorb phosphorus that humans are putting into the lake.
While the floating wetlands did seem to make a difference, there was no hard evidence that they would work throughout the lake. So students from North Idaho College and scientists from state agencies and the University of Idaho joined volunteers from the Kootenai Environmental Alliance for an experiment. They would construct and place 8 new floating wetlands.
We start with a matrix. The mat is made from extruded recycled plastic bottles. It is a dense material that creates condensed amounts of surface area for microbes to grow on. We layer the top with mulch, and then we cover the entire matrix with sod. So we plant native wetland plants that have the highest phosphorus uptake. We chose common rushes, water sedges, and monkey flower. The students were weighing and measuring every molecule of mulch, each plant root, as well as all of the sod that was there, and taking phosphorus samples from each. At the end of the season, we will reweigh and measure the phosphorus amounts on each island to see how much phosphorus they can uptake in a single season.
And once it's in the water, that'll go over again.
4 of the floating wetlands were placed in the north end of the lake, where the water is shallower and has a higher nutrient load. The other 4 go to the south end, in deeper, colder water. Students will come back through the summer to take water from within the floating wetland and from several points around it.
So we'll see, do the plants grow more on the north end or the south end? Or are we seeing the same results in both biomass and water quality on each end? We'll see.
And months later, what did the science tell us?
The experiment was successful. We were able to complete the full experiment, but the results just weren't what we were hoping for. The floating treatment wetlands didn't take up as much phosphorus as we'd hoped they would.
I think we learned that science is messy. When you do a science experiment outdoors, it can be difficult. The wetlands in the northern end grew very well. The ones in the southern end that were exposed to large amounts of boat wake washed off completely within the first month.
Still, everyone thinks the experiment was a success because it made new connections and got people thinking about improving water quality. So Kronobah is not giving up.
This is the first attempt of these ever being used on an open water body system, and we will continue to look for technologies that utilize biomimicry that maybe not immediately affect the water quality, but over time can improve things.
There are other methods. We're learning all the time about how to control these blue-green algae blooms.
We are all committed to finding a solution for clean water. Swimmable, fishable, drinkable water is the ultimate goal.
The beauty of these lakes depends upon water conditions staying in balance. For this is more than just a pretty place. These lakes represent our children's inheritance. For hundreds of years, the Coeur d'Alene tribe called these waters their home. This was a part of their culture, and plants found in the lake were a major source of food.
Water potatoes are an indigenous native species plant that grows here in our lakes, and it produces a bulb that grows under the ground. It represents the last of our harvest that we collect before the wintertime, so it's a very special plant to the Coeur d'Alene tribe.
But problems like toxic blue-green algae prevented the tribe from accessing some of their most fertile growing fields.
You don't want humans entering into waters when the water itself could be toxic to humans and pets and other critters.
But scientists, the tribe, lake managers from all area agencies are working to restore balance to these once contaminated waters. Each October, the Coeur d'Alene tribe invites young people from around the area to learn about traditional native practices, including collecting water potatoes. And cleaner water means a new generation can experience an ancient tradition.
I'm going. We're heading down.
We provide the shovels, the mud boots. Some kids don't like to get muddy, but most kids really enjoy that part.
I'm kind of stuck. Seriously.
They just get to muck around in the mud and dig up water potatoes.
The water potato.
It's something that I haven't thought a whole lot about in my life. Just assuming that water would always be okay, that it would always be good. But then you realize how close we are onto the verge of having issues with water quality that are dangerous. And you don't realize at the turn of a dime, things can change and we won't be able to access our water. We won't be able to access the water potatoes. We won't be able to make the spiritual connections with our water. We don't want that to happen.
It's very difficult every year for us to find a place. It gets frustrating that we don't have enough throughout the year. Tribal members and tribal families a long time ago used to get baskets full. We're lucky to get, even a 5-gallon bucket. and that's not enough to last. So it's important for us to try to keep going as long as we can.
The children get to taste an ancient staple and learn more about culture. And the adults, who struggle year-round to understand the science and maintain clean water, get a chance to see why their work is so important.
The responsibility for water quality rests on each and every one of us.
Felix Aripa, who is a really treasured elder for the Coeur d'Alene tribe, says water is the life of all of us. And it really is. You can have all the wealth and all the infrastructure in the world, but if you don't have clean water, then you don't have life.
Funding for Outdoor Idaho is made possible by the Laura Moore Cunningham Foundation, committed to fulfilling the Moore and Bettis family legacy of building the great state of Idaho, by the Friends of Idaho Public Television, by the Corporation for Public Broadcasting, with additional funding provided by the National Science Foundation and the National Science Foundation's EPSCoR program.